How's it? My name's Gordon, and welcome to this week's C# video where we're going to cover some basic loops. Loops are pretty fundamental to programming. They allow us to do an operation until a certain condition is met. So let's take an example of some instances without a loop. In this case, I'm printing out the numbers 0 all the way through 9, which if we had to go and run this, would just print out those numbers as you can see in order. Now in this case, if the desired output was just to print those numbers, we could obviously just print out a string literal like this, but that's not the point here. Let's say we had something a little bit more real world. So we call off some code that lives somewhere else. Then we want to check if that work is complete. We want to say the work's complete and we'll return out. And in the instance where the work is not complete, we'll go ahead and write that we're still working and then wait for a second. Now, if we didn't have loops, what we'd need to do here is go and say, well, let's try that again. So again, we'll check if the work is complete, let's return, otherwise we'll work and then we'll sleep and then we'll do that again. So let's see how this code runs. You can see that when we hit run, it says it's still working, it's still working, it's still working, now it finished. So at no point did it say it was complete. Now, if we don't know how long that takes, and generally, as a rule of thumb, if you're ever writing code that looks something similar to this, no, you're probably doing something wrong. Let's say if we did want to continue seeing how long this takes, we can go ahead and just throw a couple more of those statements in there and see what happens. You can see now it says it's working, it's working, it's working, it's working, and after a while it'll say, okay, I'm complete, and it'll finish off. Importantly, not only is this a lot of code, but if we wanted to change anything that happens in these blocks, we'd have to go and change this repeatedly throughout all of this. So then you might think, okay, well, we could just move this code into its own method and call that method, and it wouldn't be that bad. And while you're sort of correct, that's not really the point here. The point here is that there's a better way to write this code. And the reason for that is that we don't know how long this work would take to complete. It could be 5 seconds, like in this case. It could be 10 seconds. Maybe it's a minute. We don't always know what factors would come into play to determine how long something would take to run. So instead what we'll do is we'll refactor all this code into a simple while loop. So again, we'll start some work and then we'll say, while the work's not complete, print out that we're working, then wait a second, and then continue doing that until this work's complete. And finally, when we're done, we want to write out that the work is complete. Now note, in a real world scenario, you might need to cater for what happens when this takes too long. So maybe you want to have some sort of a timeout in here that will exit this loop. But in this case, it's pretty fun to just illustrate the usage of a while loop by just doing the code this way. So now if we go and run this code, you can see that it'll work exactly the same way as it did before. It writes out working for a little bit, and then eventually it says it's complete. But this code looks a lot cleaner, and now we're using the features of the language that we should be using in order to achieve the same outcome. So for simplicity, what I'm going to go and do is just create a simple while loop. So we have a integer r, and while the integer r is smaller than 10, we're going to write out that value, and then we're going to increase the value of r. If we go ahead and run this code, you can see it prints out 0 through 9, which is the same thing that we had before. So the way while loops work, as you can see, is we check the condition, and then if that condition is not true, then we do the work, and then we check the condition again, and so on and so on. Now, instead of checking a condition first and then doing some work, maybe what you want to do is do some work and then check a condition. So you want to say that we want to do this at least once always. And then if the condition's met, then we'll only stop. So in this case, we'll go and run this again. And you can see that the output is exactly the same. Again, the difference here being that if this value was 99 and we ran this code, we'd only write this out once. Whereas if we had the other code and this was 99, then nothing would get written out because the condition's checked first and 99 is greater than 10. Therefore, we're never going to run this code. So our next loop, which is similar to the while loop, is a for loop. So you can see we have all those same pieces of code, just sort of formatted differently. So we have var I equals 0. We have our condition here, and then we also have our incrementer. And then obviously the work that we're doing is just writing out. So if we go and run this as expected, you'll get the same output as what we had before. Normally, you'll use a for loop when you want to do something a certain amount of times. So like in this case, I want to do stuff 10 times. Or if I want to do something for, say, the length of an array, then you would go and use a for loop versus a while. In the end, the for loop is a lot cleaner than the while loop. So that might be a reason why you might choose to do the for loop instead. Next up, we have a for each. So the for each looks very similar, but instead of you declaring a sort of upper limit or a condition that needs to get met, what you do instead is say, go through everything that's in this collection or list. So in this case, I have a list that has 1, 2, 3 in it. And yeah, I'm going to say for each item in the items, write out the item. So if we go run this, you'll see that we get 1, 2, and 3. So in order for you to use the for each, there's actually just one method that you need to implement to be able to use this syntax. So if we look at this code, you can see that we've got a group of people. We've added 3 people to that group. And then currently we've got a red squiggly here. So by default, you're not just going to be able to iterate over things that in English sound like you would. So in this case, I've got a method that says get. So yeah, I add people to that list. I then get the people back out the list, and then I write them out. So over here, I add people to that group of people, and then I tell that group of people object that I want to get the list of people, and then we write out each one of those people. Now, although this does work, it just doesn't look as nice. So what you might want to do is if we go to this group of people, you can see currently here's our get method. Instead, what we want to do is change this to an R enumerator. And then instead of it being a get, we'll say it's a get enumerator. And then on this people object, we'll say get enumerator. And obviously in this case, I'm just backing this by list for simplicity of this example. But in the case where you have this group of people, this collection, you're probably going to have a lot more logic in there, which is probably why you have that group of people. But you can see that this has gone red now. So if we remove this, you can see all the squigglies are gone. And in this case, if we go and run this code, it works as you would expect, and we get the list of people. Now, from an API or sort of SDK of using our group of people, this is a lot more intuitive. We have a group of people, we add some people to that group, and we want to be able to for each over the list of people that's in that group. And you can see in this case, we didn't have to go inherit from like an R collection or an R anything else in order to use this functionality. Because if we did inherit from, say, R collection, there's a lot more methods we need to support. If all we wanted to do is do a for each over that, the only requirement for that is this get enumerator method. So something that I haven't shown yet is what happens if you need to stop this loop early. So let's say, for example, we want to loop through here until we see the name Jane. What we could do here is say that if person.name equals Jane, we want to break this loop. And now if we go and run this, you can see that only John is printed out. But what happens if we want to say, well, if it's Jane, we don't want to continue with what the work is, but we do actually want to continue. Well, in that case, you can simply go and replace break with continue. And if we have continue there, that'll just exit this instance of the loop and go straight back into the next one. So now if we go and run this again, you can see that we have John and Joe. And that's because when we did this validation on the name and we saw that it was Jane, we just said continue on. So it stopped here, went back into the next iteration of this loop, and then continue on from there as normal. But something that's more interesting about all these loops, which I wasn't thinking to include when I was thinking about doing a loops video, but it was something that came up in a conversation with Sam Wagner a couple of weeks ago, is that all the types of loops we've looked at today are all just syntactical sugar for one specific loop. And that loop is the while loop. So you can see if we had this code, which we started out with originally in sharplib, when we showed sharplib a couple of videos ago, you can see that the resulting C# at the lower sort of C# level is a while loop. Now, when we have a do while, you can see that what we actually have here is a while true. So while this is true, we're going to do the work that we have inside, which is writing out and incrementing our integer. And then if the condition is met, we're going to break out of that loop. In the case of our for loop, it goes back to pretty much exactly what we had before. So it has the integer, while the number is smaller than 10, do the work. And then lastly, for our for each, we get the enumerator, and then on that enumerator, we say while move next. We write out the current item in the enumerator. And then finally, assuming that there's something in here that breaks, we'll go and dispose that enumerator. So that's all I wanted to share today for basic loops. These loops are all synchronous. In another video, I will cover some more advanced loops. Remember to like and subscribe. If you have any thoughts on loops, or maybe what I should do in the next video on the more advanced loops, please leave them down below in the comments. I'm Gordon Beaming, and until next time, cheers.